For the second part of 7.1, we're going to be looking at what are called polyatomic ions. We've already looked at monatomic ions, and now we're going to look at poly. So monatomic meant one, poly is going to be many. So we're going to have many atoms put together to make one ion. Usually it's two, sometimes it's three, but for the most part, it's two. Here is a chart of many of the polyatomic ions that we will be using. You have this chart or a similar chart in your classroom, so you can refer to that and you'll need it definitely as you do your homework. A couple important things to look at. Some of these are very similar. So this one is sulfur with 3 oxygens that have an overall -2 charge. The charges are superscripts, and then how many of each we have are subscripts. So to help you kind of understand what these numbers look like. Sometimes, again, we have this one has 2 oxygens, this one has 3, so very, very close difference. In O2, 2 oxygens, and then there's a charge, a -1 charge that's up above a subscript. So if you have questions about reading these charts, let me know. But you'll notice here, these are all -1, these are all -2, -3, and we only have one that has a +1 charge, and that's ammonium. So starting off, all of them are negative except, like we said, ammonium. And most of them are what are called oxyanions, or they contain oxygen. Many of them only differ by one atom. So here you can see the difference of NO2 and NO3, nitrite versus nitrate. And so the one that has more oxygen is going to end in ATE, and the one with less oxygen ends in ITE. Now, if you remember in our monatomics, IDE meant that there was only one negative in that ion. Now we're seeing other endings, ATE and ITE. So by looking at the endings, it can kind of help you know, is this a polyatomic? Is this monatomic? Now to write these formulas, we're going to again use the crisscross method, but we have to keep all of the atoms in a polyatomic ion together. So we are going to be putting parentheses around our ions. So we would make sure we keep all of that together, except the charges stay outside of those parentheses because we're going to be crisscrossing the charges outside. So for the first one, NH4 is in parentheses there. CO3 could still stay in parentheses, but we're crossing down a 1, so it won't make a difference. But we're crossing a 2 down here, and that 2, just like in math when we are multiplying things inside parentheses, that 2 is going to tell us now we have, instead of 4 hydrogens, 8. And then instead of 1 nitrogen, we have 2. Over here, if we had parentheses around this, and we cross the 1 down from ammonium, 1 times 3 and 1 times 1 isn't going to change it. So if you want to keep those parentheses, fine. If you don't, that's fine too. Looking at the next one, Ca with a +2 and BrO3 with a -1. We're going to put parentheses around the BrO3. So the 2 from the Ca comes down, and the 1 from the BrO3 would come down here. On the next one, we've got Al with a +3 charge and SO4 with a -2 charge, parentheses to keep our SO4 all together. So the 3 comes outside the SO4 parentheses, and then the 2 comes down for the aluminum. So in this formula, we would have 2 aluminums, 3 sulfurs, and 12 oxygens. And I know these parentheses are a little funky, but that should be including the 4 inside. K with a positive 1, PO4 with a negative 3, parentheses around my PO4. And so I have K3, and then the 1 comes out down here around the PO4. And so again, if you want to put a parentheses, if you don't, that's fine too. And now naming these polyatomic ions. So you're going to need that chart handy. So if we go back and kind of look at that, you need to have this chart handy to name some of these ions. So when we name these polyatomic ions, we don't have to change anything from what the chart says. So if we see NO2, we know it's nitrite. If we see CO3 with a negative 2, that's carbonate. So you're going to basically read the chart to figure out how to name these. So if we go ahead a little bit, so we know Li with a +1 is just lithium because that's one of our monatomics. Then we're going to look up CrO4 with a negative 2 charge on our chart. And so we would just write lithium chromate. Here we have NH4 with a +1. That's the only polyatomic with a positive charge. And so we'll look up NH4 on our chart, and that's ammonium. And then SO3 with a negative 2 charge, and that's sulfite. So we would just write ammonium sulfite. Sometimes people try to write nitrogen hydride, sulfur oxide. No. Make sure you're just looking up these polyatomics on the chart. Next, magnesium, because it's just a +2 monatomic. Cn, negative, that's a polyatomic, so look on our chart, and we find magnesium cyanide. Ca, by itself, monatomic, so it's positive, so it's just calcium. And then CO3, negative 2, looking up on our chart, we find out calcium carbonate.